Okay, I think from previous videos, one of the things we talked about was creating a tight home, and we talked about zip, and we talked about door pans, we talked about sealing with caulk, and various things, and actually now I'm here with Ross, and we're actually going to test how we've done with all those parts, and so Ross, maybe go over a little bit what you're about to do.
Yeah,
to
absolutely.
kind of.
So basically what I'm about to do is I'm going to run a blower door test on the house where I'm going to depressurize the house and pretty much displace all of the air in the house. So what's basically going to happen is the air out has to equal the air in. So it's going to come in from different points, but the tighter your house is, the more caulk you have, the more sealing around, basically the less air infiltration you'll have, which will make your house more efficient and require less energy.
And kind of, I think one of the things we were talking about in one of the videos with duct sealing, that being another part of this test, not that we usually do is we test the duct tightness, and for energy savings and pollution too, right?
Absolutely. So yeah, basically we will run a couple of different tests. As I already mentioned before, the blower door test kind of measures the efficiency of the house in general and how well it has been sealed up. But the duct test will also test how leaky your duct system is, and where if you're losing air into your attic and wasting energy into unconditioned space. Same concept as the blower door, where you isolate a space and depressurize or pressurize and see how much you're getting back.
And how do you see this? How have you seen these tests go in terms of for people's homes? I mean, you probably see a wide range of results, right?
Very wide range, very wide range.
So one of the things we're looking for is to see how well we've done, I guess, gives a homeowner a better sense of, how well we're doing, right?
Exactly, yeah. So these tests, obviously none of this equipment looks very familiar to everyday people. However, to kind of give you some parameters as far as standards you go, when you're doing a blower door test, is for North Carolina, you want your house to be under 5 air changes or less. And that'll basically kind of mean that when you're using a blower door, it will displace all the air in the house 5 times an hour. So that's kind of your basic standard, and the calculation is done from a formula based on the volume of the house.
Okay.
So you take the square footage and multiply it by the wall height, and you get your volume. And that's kind of the parameters. You'll gain a number off of this manometer here and put it into the equation. That'll kind of give you an idea of where you are. He has always landed well underneath those North Carolina standards and adhering, which is actually a very rigorous standard throughout from the entire country as a whole.
Right. Mm-hmm. Okay, so that's the objective, is for Ocean Grove cottages to be under that way under that standard as best we can. And obviously, I think we all know that, it depends on the quality of the doors. It depends on a lot of factors.
Absolutely.
And it depends on the shape of the home too. Mm-hmm. So there's range, obviously going to be a range, but the object is to get under that standard. And the other factor too, I think, you have to have some fresh air, or you have to have a fresh air delivery system.
Exactly.
Once you get too tight. So,
exactly.
So you can't go sealed like a refrigerator,
yes.
where you eliminate the ice. So there's a happy
medium there in between. So I mentioned the 5 air changes before. Anytime you get around under 2 air changes per hour, that's when you want to kind of start thinking about fresh air ventilation coming from outside and then conditioning that air. But however, anywhere from about the 2.5 to 4.5, 5 range is the happy medium that we're looking for.
The sweet spot.
Exactly.
Yeah. Well. Okay. Well, I think that gives us an idea of what we're doing, and I think we might point out how we're doing some of the elements of the test. We have to seal off the ducting from the blower door and so on. That basically shows us what we're about today, and now we're going to run the test and see what the results come in at.
So right now we're about to start the blower door test. Basically, you have to go through a couple procedures before you do that. Make sure that all the windows and doors are closed and any kind of connection to the outside. You want the house to simulate as final a house as possible, as close to final as possible. So right now I'll go ahead and start up the test, take a baseline reading, and then just get it going. You'll see how the door kind of moves inward as everything's being depressurized. It kind of sucks the house in versus a pressurization where it would do the exact opposite and push it out. So you can kind of hear that the fan isn't working very hard, which is a good sign. It means that it doesn't require a lot of energy to displace 50 pascals. And right now our number is coming in at a just 950s area, which is extremely tight for a house this size. And you kind of want to leave it running maybe sometimes for if you're trying to find problem areas in a house. And but with a house such as this that's this tight, usually I won't go through that process unless it's needed.
Okay, so Ross, you've done the calculation for the volume, and you've done the calculation for the loss, and so now you come up with your figure as to how many things. So how do we do?
So as I stated before, North Carolina Code is kind of wants it to be underneath 5 air changes per hour, and this house came in at 2.76 air changes per hour, which is well below the typical standards, and kind of just shows that this house is going to be a very efficient house, and along with the duct test being tight as well. Everything's looking like the utility bills will be rather smaller than your typical 90s house or 2000. Let's hope.
Well, great. Boy, that's good, Ross. That sounds like kind of what we're looking for. Is give, it kind of closes the circle in terms of, working on tightness is not just working on tightness. It's actually delivering a kind of a miles per gallon for the house, and I think that's what has Ross doing what he's doing for just the energy expenditure for the state, and just creating better energy efficient for all of our homes. So thanks, Ross, and that's kind of I think why we're so passionate about doing a tighter home, and not only for ourselves but as a builder, just doing it for our homeowners at the beach here, so that they can. And I think the other thing is it delivers that air change per hour means that you're in control of your thermal envelope, as opposed to nature being in control of it. So all of a sudden you're delivering more comfort, which I think is another part to this equation. It's comfort for the home. The HVAC system can deliver better air temperature without straining. So that's really what we're after, is kind of a more relaxed delivery of the energy. One of the things you were saying was five air changes an hour for the state requirement. But what have you found on older homes? What is maybe some reference for us to give us a sense of what's older houses? What have you found in terms of your work?
We test all kinds of houses. We test new construction back and doing existing audits as well. And kind of what we found when we go back, and it really kind of changes decade to decade. But typically, what you'll find on average, I'd say about 10 to 11 air changes per hour on houses that are built 20 years back, 10 years back even. And the standard came out, the 5 air changes per hour came out relatively recently because of those kinds of reasons. People were having comfort issues and durability issues as well, which is why the standard kind of got set in place at about 5 air changes per hour.
And some of the worst ones you found them up? Yeah,
I mean, they get bad. I went to a house, and I think the worst one I saw was about 25 air changes per hour. So you can imagine it's going to be quite drafty, and on a windy day, you can feel it coming in from you at all angles. And it really kind of limits your HVAC, the ability of your HVAC equipment and everything else in your house, because it's kind of jeopardized when you don't have a tight thermal envelope meeting your air barrier as well. So.
And I would guess in terms of maintenance on an HVAC unit, you talk about working 5 times as hard as what
absolutely. So you're greatly diminishing the longevity of your system as well as its effectiveness on a day-to-day basis.
So for all those reasons, that's why we're passionate about this. You too.
Comfort and saving money, that's what we're about.
Right.
Absolutely.
Okay, so I think that gives you an idea of a reference point for us. So thanks.